Okay, so this is the next question. What is the value of the flux of vector field F defined on R3 by f of x, y, z is equal to xi vector, positive yj vector, positive ck vector through the surface z is equal to root of 1 negative x squared negative y squared, oriented with upward pointing normal vector field. Okay, please go through this question, attempt the question, and let's see when we come back the solutions choice. Okay, now there is a very important observation you will have to make here. The given surface is part of a closed surface. Okay, and the vector field is radial, so we use divergence theorem, so which is given by the formula flux through the full sphere is triple integral for the surface del dot f vector times dv. Now del is dou over dou x I vector positive dou over dou y j vector positive dou over dou z k vector. So del vector dot f vector is given as xi vector positive yj vector positive zk vector. So del dot f is going to be dou over dou xi vector positive dou over dou yj vector positive dou over dou z k vector dot xi vector positive yj vector positive zk vector. You take the dot product, you get dou over dou x of x positive dou over dou y of y positive dou over dou z of z. This is going to be 1 positive 1 positive 1, which is equal to 3. So therefore the integral is required integral is going to be triple integral 3 for del dot v, so 3 will come over here, so you have to integrate this v. Now the question is, how do you integrate this? You have to fix up the limits, okay, which could easily be fixed, right? So I'm going to show you how exactly we can integrate this. Okay, now the given surface, you have to know about the surface. The given surface is x squared positive y squared positive z squared is less than equal to 1. Okay, we are talking about the unit ball, so we are required to use this surface and evaluate the triple integral of dv. So if we were to rewrite this, this is going to be equal to 3 times of, now we have to fix the integral limits. Now this dv is going to be r squared sine theta, not sine square, sine theta, r squared sine theta times dr d theta times d phi. Okay, and the limits will be 0 to 1, 0 to pi, 0 to 2 pi. So I'm going to show you how to integrate this. So foremost, let me just split this off. Okay, so required is equal to triple integral 0 to 1 r squared. I'm going to integrate this times sine theta d theta d phi. So when it comes to d theta, this is going to be 0 to pi, 0 to 2 pi. So what we will do is we will first consider integral 0 to 1 r squared dr. This is r cubed, you have a 3 there, over 3, limit 0 to 1, which is going to give you 1 over 3. So this is going to be 3 times of 0 to 2 pi, 0 to pi, 1 over 3 sine theta d theta. This is d phi. Okay, d phi. So 1 over 3 can be brought out. So you have 0 to 2 pi, 0 to pi sine theta d theta. So this is going to be integrated and d phi will follow. So 3 gets cancelled. This is equal to 0 to 2 pi. Integral of sine theta is negative. So you have cos theta is 0 to pi and d phi. You integrate this, you get cos of pi, negative cos of 0. Okay. This is 0 to 2 pi with a negative sign and d phi. Cos of pi is negative 1. Cos of 0 is 1. So this is d phi 0 to 2 pi with a negative sign. This is negative 2, so you get a positive 2 because of the negative sign. So 2 times 0 to 2 pi of d phi. You integrate this, you get phi. Limits are 0 to 2 pi, you have a 2 there. So this is 2 times of 2 pi minus 0, which is going to be 2 of 2 pi, which is going to be 4 pi. Okay, so but we need the flux for the upper hemisphere. Okay, so we divide by 2. This is nothing but 4 pi over 2, which is 2 pi. Okay.